Okay, 7th grade, we're going to switch up gears a little bit here and do a little review on perimeter and area. This will become increasingly important for next year when you get into finding volumes and doing work with transformations. Okay, we know perimeter to be the measure of linear units around a two-dimensional figure. Okay, and when we think of a simpler definition, we're simply going to find the sum of the lengths of all the sides. So an example that I like to bring up, it's kind of like a yard fence. You're going to add up the lengths of your yard fence to find the perimeter. Okay, so you're going to find a fence, or find the length of the fence around the outside of all of these objects. So on this particular example here, we're going to add 17, 13, and 10. We simply know that to be 40 inches. So perimeter of this scaling triangle is 40 inches. Okay. A quick review of area. Remember, perimeter is the length of the outside of an object, and the area is how much space is occupied by the inside, how much space an object takes up. Okay, so that's why we have different formulas here. For this square, area is side times side. In other words, that's just side squared. Okay, the most universal formula you will see is base times height. Area is base times height. A lot of times you'll go length times width. You'll hear that. It's the same thing. For this video, and most commonly in my class, you will hear base times height. Don't get confused with those terms here as we go here. Find the area and perimeter. Alright, so let's find the area first. We check back to our formula, base times height. We have a base of, well, we have nothing down at the bottom of this rectangle, but if this is 6 at the top, we know this is going to be 6 down here. Likewise, this 15 side length over here. Okay, so area is simply base times height. So let's just plug in what we know. We know the base to be 6. We have a height times is 15. So 6 times 15. That's going to be 90 inches. And whenever we're finding area, we put this little 2 up here for squared. So 90 square inches is what our area will be. We'll switch colors and we'll find a perimeter here. Perimeter is pretty simple on this one. We're just adding all the way around. So we're just going to find the sum of all of these side lengths. 15, 15, and 6 and 6. We will add those together, and that'll give us 42 inches. We don't put the squared on the perimeter label. Okay, labels are very important. Don't forget to do that throughout this whole unit and on your assignment. Okay, we're looking at a square here, and what do we know about squares? Squares have all equal sides. So if it helps you, go ahead and label each side with the side length. Alright? And now we're set to find area. We're going to find area first by simply going 4.5 times 4.5, because that's the base and the height. Remember, they're going to be the same on a square. 4.5 times 4.5 is going to get you 25 hundredths. Millimeters squared. Remember, labels matter. Okay, now on to perimeter here. Going to add all the way around. In other words, we're going to take 4.5 times 4, because there's 4 side lengths, all measuring 4.5 millimeters. So 4.5 times 4 is going to equal 18 millimeters. Remember, you can also do this as an addition problem, as we talked about. We're going to find the sum of all the side lengths. Okay? Quick little review of area and perimeter there. We make this one just a little bit harder. The area of a rectangle game board is 180 square inches. Okay, so notice they are giving you the area on this. It has a length of 15 inches. What is the width? So go ahead and draw this up whenever you're faced with an example like this. We know the area of this to be 180, but that doesn't give us our side lengths, but we do have one here. It has a length of 15, so this is going to be 15. Okay, so if that's the length, maybe this will be the width. Alright, so if we think back to our formula here, okay, length times width equals our area. told us our area is 180. Well, we can plug and play with this 15. So 15 times W, or in other words, 15W equals 180. How do we isolate the variable here? Divide by 15, divide by 15. Our width is going to equal 12 inches. If we wanted to check ourselves on that, we'd go back to our basic area formula and go length times width, which is 15 times 12, and that should equal 180. Okay, switching to something a little bit different here, we're going to look at a triangle. Okay, and if you really think about a triangle and how these formulas might change, most of the time it's pretty easy to see, especially for this one, that a triangle is basically half of a rectangle and or square. Okay, and so that gives us a formula of base times height divided by 2. Okay, since it's half. The tricky thing about triangles is knowing which side length to use. Let's take a look at this 14 here. Does that give us a base or height? Well, I would say that this 10 would be our height, and our base definitely wouldn't be 14, it would be this other 10. Okay, so in this example, we're not even going to use that 14 here. Okay, so our base and our height is 10, so we're going to go 10. If I can get this to work today. 10 times 10 divided by 2, because that was our base and our height. That's going to equal 100 over 2. Our answer is going to be 50 centimeters squared. Okay, now we're going to find the area of this scaling triangle. It's not quite as easy because our height isn't as easily to see in this orange one here, where our height was this one right here, and that side length right there gave us a pretty clear height, where this one, they have this dotted line here. Alright, once again, we have useless information unless we're talking about perimeter. They're just asking for area on this one, so we need to identify a base times a height. Okay? Our base is pretty easy. We're going to look at our 10. We're going to take that times the height. Now, which is the true height here? Is it 12 or it's 15? The shortest distance from the top of this figure to the bottom is going to be our 12. So we're going to use 10 times 12. Remember, we have to divide by 2 when we're finding area of triangles. So that's going to be 120 divided by 2. Our area is going to be 60 meters squared. Okay, another example where they're going to give us the area here, and you'll have to find a side length, kind of work backwards on this one. Okay, the height of this triangle is 6. I'm going to go ahead and put that on there. And the area is 24 square meters. Okay, so that's the area that this object takes up. Alright, what is the length of the base? Okay, so you could either put an L. I'm going to go ahead and put a B on that one. Second thought. Okay, we'll go back to our basic formula here. As base times height divided by 2 equals the area. Now we can just plug everything in that we know. Our base we don't know, but our height is 6. Alright, so B times 6, in other words, we'd have 6B over 2 equals the area, which is 24. Alright, now we just have to simplify things out a little bit here. Reduce our fraction, we'll get 3b equals 24. B in that is going to equal 8. Don't forget your labels. What are we looking at here? Looks like we're in centimeters, so our base is going to be 8 centimeters. We could easily plug that back into our original formula, base times height. divided by 2. 6 times 8 divided by 2 gives us our area, which is 24. Good way to check yourself on that one. Don't forget that little trick on the assignment. Okay, area of parallelograms. What is the true height? So a lot like the example we did here a little bit ago, we look down here at this parallelogram at the bottom where we have a 6, an 8, and a 7, and we're trying to find which one is our true height. It's either going to be this 8 or it's going to be our 7. We see the side length that this 8 represents is slanted. It's not the shortest distance from the top to the bottom. So for our base times height, we're going to plug in the 6 and the 7. 6 times 7, 42 feet squared for our area. Okay, so we really have to be careful there that we don't misuse or mislabel our height. That 7 is going to be the height and not the 8. Moving on to trapezoids here, probably one of the more difficult formulas that you'll deal with. Most of the time they're going to give you this formula, so I'm going to go ahead and write that up there. You've probably seen this before, but it's tough to remember because it is kind of long. Base 1 plus base 2. Okay, we're going to add the two bases times the height, and then we're going to divide by 2. Okay, so if you recall, a trapezoid, what's the definition of a trapezoid? Well, it's a quadrilateral with only one set of parallel sides, so that's why you have two bases. Let's look down at this example here. We have 2 units for this lower base. 1, 2, 3, 4. Alright, and what's our true height? Okay, from there to there, we'll count 3, and now we have everything we need to find the area of this trapezoid. Our base 1 and our base 2, doesn't matter which one you plug in for either one. I'm going to plug 2 and 4 into those boxes. We'll take that times our height. Our height is 3. We have to divide by 2 because we're involved with the triangles. Okay, we go 4 plus 2, which is 6, times 3 is 18. Okay, 4 plus 2 times 3, that's going to be 6 times 3 is 18. Divided by 2, we're going to get 9 square units there. Okay, a quick little overview of what we did here. Feel free to use these formulas. Feel free to jot these down before you jump into your assignment here. Remember, squares and rectangles, we're simply going base times height. Okay, where triangles, we'll have to go base times height divided by 2. Okay, parallelograms are, once again, we're just base times height. Make sure you identify the true height. And when trapezoids, here again, we'll have base 1 plus base 2. Take the sum of those times the height and divide it all by 2. Okay, gives you a quick little overview. Most of that you should have at least seen before. Take a look at the assignment here. I'll flash it up here. Take a look at, for example, number 3 here, if I can get it to blow up a little bit here. Alright, they labeled the true height for you. Okay, and so this red sign right here where it says 5.7 meters, that's going to be your true height on that one. They didn't try to trick you by labeling any other side, so make sure you put the right side lengths into play there. Okay, good luck on that. Send it back to me when you get it done. Have a good week.